And we think that humans, on average, have up to 100 trillion cells. So it depends on how big I am, a 100-pound person versus a 200-pound person versus a 300-pound person. The difference is in number of cells. It's not that the 300-pound person has the same number of cells and they're just like 3 times bigger. They have more cells. So if you have a person with a liver this big, because they're a 5-foot-tall person, and you have a 6-foot-tall person and their liver is bigger, each individual liver cell is the same size about, but the bigger person just has more liver cells. So more grains of sand, so to speak, in like this like beach of life. So how much, if I was trying to figure out like how long that is, like if I'm 100 trillion cells, and that means I've got 600 trillion feet of DNA, like how long is 600 trillion feet? Like I know it's 600 trillion feet, but like how long, like put that in something that I can kind of comprehend, yeah. In a human cell. So different animals or different plants have different numbers of chromosomes and a different amount of DNA. Like plants, for example, have more. How long is the distance? If I was looking at 600 trillion feet, like where does that go? Just one of those deals where it's like, that's the distance between Timber Creek and whatever. Like, give me something. Or is it in miles? Like what? Yeah. Okay, a couple million miles longer than the Earth to the Sun. It's longer than that. So here's how long it is. Here's the Sun. There's the Earth. That's supposed to be capital. My fault. No disrespect, Earth. So to give you an idea how far away the Sun is from the Earth, it takes 8 minutes for light to get here. And light travels at, the speed of light. So that is 1 billion meters a second, right? 1 times 10 to the 9th meters per second. Isn't that the speed of light? So it turns out the Earth at the equator is around 24,000 miles around. Light at the equator can lap the Earth multiple times in a second. That's how fast light travels. So it takes 8 minutes for light to get here from the sun. So the classic thing, like if the sun exploded, we wouldn't see that for like 8 minutes because it takes that light of the explosion 8 minutes to get here. So if it looked like the sun was exploding, that means the sun exploded 8 minutes ago. So the sun is 8 light minutes. You've heard of like light years. Something's this many light years away. It's 8 light minutes away. So the distance from the sun to the Earth and back, that'd be another 8 minutes. It can make that round trip 100 trillion feet, can make that round trip 667 times. So it's the distance between, I know. I knew that would happen. Of all the things, is it really 667? Yeah, it is. So I do that and back, that's 1. Do it again, that's 2. Do it again, that's 3. That's how much DNA I have in my body. Now, my source for this, I feel like you guys at this point in the year generally trust me, but if you say something super outlandish, you get a source. So here's where they basically compiled from a bunch of like textbooks how much DNA is in a cell. And so they settle in the modern number is about 2 meters, so about 6 feet. And then they kind of do the math. Here's how the distance between like a base pair, here's the number of base pairs per cell, here's the number of cells in the body. They're using 10 trillion. So we think that we're closer to 100 trillion. So they're doing 10 trillion. So 10 trillion, if we were 10 trillion cells, that would be 67 trips, round trips to the sun from the Earth. But if we're 10 times as many cells, if we're not 10 trillion, if we're 100 trillion, then it's like 667 round trips. So how do I keep that DNA from getting tangled up? Histones. How did I get DNA to stick to histones? What chemically would cause DNA to be attracted to histones? Yeah, polarity. What was the charge on DNA? Negative. What made it negative? What part of DNA was negative? Phosphates. Good. So in this class, anytime something's negative, it feels like at least half the time it's phosphate. So if I look at DNA, the outer parts of DNA, phosphate, sugar, phosphate, sugar, phosphate, sugar, are negative. So your DNA might not be identical to mine because you're not my twin. It doesn't matter the order of A's, T's, G's, and C's. The edges of DNA are always negative. So the DNA in a plant, an animal, a fungus, a bacteria, whatever, it's always negative. So histones are positive. To appreciate the number 1 trillion, I thought of one other thing. So how long is a trillion seconds? Like obviously it's a trillion seconds. But how long? Did you say 30,000 years? That's actually really close. So we can figure that out. We can go back to 10th grade chemistry. Let's say I've got 1 trillion seconds. Million, billion, trillion. So I'm just trying to get an appreciation for like how big of a number is a trillion. Like when I hear that somebody is worth like $100 billion or something like that, and all right, so that's like a tenth of a trillion. Like how much is that? So if we're looking at a trillion seconds, that's a trillion, million, billion, trillion, a trillion seconds. And to figure out how many years that is, there's 60 seconds in a minute. There's 60 minutes in an hour. Oh, the good times of years gone by. There's 24 hours in a day. There's 365 days in a year. And if I take that, divided by 60, divided by 60, divided by 24, divided by 365, I get 31,709 years. That's how big a trillion is. A trillion seconds is 31,000 years. I'm not a trillion cells, though. We think I'm 100 trillion cells. So 100 trillion seconds is 3170900. 3 million years. Crazy. So who said that you would never use this? No, you can't. Right. Bust that on a date, you'll seal a deal. Probably later on. I'd say date like 8 or 9. So I proposed. Got down on one knee, got out a little paper pencil, and I was like, will you marry me? And she was speechless. Like, oh my gosh, 31,000 years, I never knew. And I was like, so will you marry me? She's like, yes, 1,000 times yes. And then I realized that was a quote from a movie that I would watch over and over again the rest of my life. It's horrible. My wife's favorite movie is Pride and Prejudice. There's a quote in there where she says, yes, 1,000 times yes. So whenever she said that, I was just like, oh, that's a cool quote. I didn't know that, I was now going to be in the presence of that movie for decades, for the rest of my life. So, yeah. The movie's horrible. How many of y'all like Pride and Prejudice? Yeah, so my wife likes it. I think it's super dumb. If you haven't seen it, I've got an entire scene where a guy talks about boiled potatoes. I call him Boiled Potatoes Guy. And he'll be like, this is the most excellent boiled potato. Might I ask who prepared this boiled potato? And you're like, oh my God. I don't know if she's read the book. Sure it is. Hard pass for me. I said I'm sure it is, but hard pass for me. It's got a setting. Rich people, the rich people have money, the others don't. There's a ball because there's always a ball. It's the same movie over and over and over again. A lot of costumes, like a whole lot of. I don't know. Anyway, so the next thing that we want to get into is so DNA. I have to wrap it around histones, otherwise it gets tangled. So whenever I wrap DNA around histones, DNA is negative. So what's the charge on histones going to be? Positive. So DNA will wrap around the positive histones. All right, cool. So the next thing that we want to look at is what are the odds you can talk with somebody around you? What are the odds that someone hears in their lifetime you have cancer? Not the odds of dying from it. What are the odds that I will hear in my lifetime you have cancer? Yep, a percentage. All right. So what do you think? 100% would be everybody does. 0% would be nobody does. So what do you think? 70 or 70 something, 72, 70, huh? 80? The most pessimistic class I've ever had. Yes, being diagnosed with cancer doesn't mean that I die from it. It's just what are the odds that a medical professional is going to tell me one day you have cancer? 30? Or just what are the odds that I'm going to get cancer in my lifetime? So this will be a type of cancer that would be like I worry about. Not just like, oh, here's a little bit of growth, whatever. This is more like, hey, we better treat that. We got to get you on chemo. You got to do surgery. We got to do radiation. We got to do something. Rather than just like, yeah, come back. We'll kind of watch this over the next 4 years. Like, we're going to do something about it. Okay, so it's between 20s and 60s, it sounds like. What are the odds? So I've got 100 people. What are the odds that they're going to hear you've got it? And then what are the odds that I die from cancer? Not of the people that got it, but of the 100? We'll say that there's no misdiagnosis. Yeah. So out of 100 people, so let's say that you said 30 of them got it, then the most that can die out of 100 is 30. That would mean that every single one of them died from it. Right. So not like a percentage of the got it, like of the original 100. So some of them won't hear that they died from cancer because they never even got it. Okay, so most of you guys are in the 10 to 20%. Okay, one last question, and I am going to show you real answers to all these. The last one, males or females, who's more likely to get cancer? All right. All right, males, 43% of males get cancer. 23% of males die from cancer. This is not 23% of the 43. This is 23 of the original 100. So I've got 100 dudes in the room. 43% of them will hear you've got cancer. 7 will never hear that. And of those same 100 dudes, 23 of them die from it. So that means there'll be 20 dudes that hear you have cancer, but they don't die from it. So I have a 1 in 4 to 1 in 5 chance of dying from cancer. All right. I'll show you the female ones. What is the most common type of, across male, female, whatever? We're going to ignore skin cancer. The reason we're going to ignore skin cancer is because that varies dramatically based on where you are on the globe. You live in Texas, South America, Central America, Mexico, all that, like you're close to the equator, skin cancer is common. If you live way up north in Canada, this is not that intense. So skin cancer varies dramatically depending on where you're at on the globe. So that one's not very universal, if that makes sense. So across the globe, what is the most common cancer? Not breast cancer. Prostate cancer. Prostate is number one, and breast cancer was a cheer. In case you didn't catch that, that was a yeah for prostate cancer. So prostate cancer is number one, breast cancer is number two. So that is true. Females do not have a prostate. That is true. Females, the likelihood that you get cancer in your lifetime is less. 8%. The likelihood that you die from it is about 1 in 5. So you're at 19%. What percentage of females get breast cancer? 12. The good news is, though, survivability is pretty high. If there's 100 females and 12 of them here, you have breast cancer, 9 of them won't die from it. 3 of them will die. It can be genetic, but the main reason is because it's external, so you have a chance of fueling it. If I have lung cancer, my ribs are in the way. Until I have some sort of really bad symptom, I won't notice. With skin cancer, I'll be like, that looks weird, potentially. So before it's ever super bad, I might just be like, that looks weird, right? How do you feel? Fine, but that looks weird. Same thing, I might just be like, oh, I don't have a fever, I have no other symptoms, but all of a sudden there's just kind of this bump. So because it's external to my ribs, my pancreas, usually we have the first time that symptoms show up with pancreatic cancer, it's already too late. Yeah, so certain types of cancers, it's just you notice something. You start feeling pain very, very early on when we can still do something about it. And other types of cancers, it's usually like when you notice pain, it's stage 4 already, and we can't do much. All right, so breast cancer was the second most common again. Females get it. 3% of females die from it. Prostate cancer was more common. Males, 15% of males, so that's 6.5 males get prostate cancer. Same thing though, out of those 15 males, 12 of them don't die from it. About 3 of us will die from it. Prostate cancer, they can check more physically. They can also check in a blood test. So the most common way that we test for prostate cancer now is like every year I go and I get a blood test, just like a general checkup type of thing. They check for PSA protein and prostate antigen. And if the numbers are really, really low, then that almost always correlates with you don't have prostate cancer. When the numbers start going up, then they can investigate further. So we can check for prostate cancer with a blood test. So we're pretty good at catching that one early. Which one, once I have it, is the most likely to kill me? So for example, because so many males get it, more males might die from prostate cancer than anything else I know. However, the survival rate is pretty good. Those that hear you got it, odds are you're going to make it, right? 15 will make it. Which one, once in this column that you got it, which one is the deadliest? Not stomach cancer. Not brain cancer. Not lung. Not thyroid. Not pancreatic. Pancreatic's pretty bad. It's got about a 5% survival rate. Not liver. You're like, wait, this one is worse than like a 5% survivability? Yes. The esophagus. That one's surprising because I just used my esophagus. I feel like I should have noticed if something was off. Again, kind of like skin, if I've got this mold and before it gets like huge, I would have just thought, like, since I'm always eating food and drinking food with my throat, my esophagus, that I would notice if something was going on back there. Again, I totally understand that I can't feel my pancreas. If I don't have very many pain receptors in my pancreas, I understand that I could have a tumor the size of my fist in my pancreas, and I might not know because I can't feel it. So I'm surprised by the esophagus. However, Look at this. Luckily, it's rare for people to get it. 0.80 get it, 0.790 die from it. So that means if 80 dudes get diagnosed with esophageal cancer, 79 of them die from it. The survival rate is less than 1.5%. You're like, I never want that one. How do I avoid it? Don't smoke and don't drink. How do I avoid colon cancer and other butt cancers? Don't smoke and don't drink. How do I avoid laryngeal cancer, voice box? Don't smoke. How do I avoid liver cancer? Don't drink. How do I avoid lung cancer? Don't smoke. How do I avoid melanoma? Wear sunscreen. So many of these things are partly avoidable. I can get lung cancer even if I live in a pollution-free area and I don't smoke. I can get liver cancer even if I don't drink alcohol. But the best predictor of whether or not you're going to get lung cancer is do you smoke. If you're a non-smoker, that number drops dramatically. It's crazy. All right. Are there any others? We've only got a few minutes left. Are there any others that you guys are like curious about? So bone cancers, if I have it in my marrow, like the most common one that you guys have heard of is leukemia. Leuko is white. When I have cancer of my white marrow, that's leukemia. What I don't understand about leukemia is this one of the only cancers that hits people when they're young. Like, I don't know of anybody at Timber Creek that has had lung cancer, but I know of people that have had leukemia. So most cancers you don't get until you're older. I don't know what it is about leukemia that you'll have like a 4-year-old kid that has like leukemia. So, yeah. So bone marrow and bone cancer. I don't know what it is, but like I don't know that I've heard of a 10-year-old dying from lung cancer. But leukemia, yeah. So, see you guys later.